Welcome back, guys. We're going to look at finishing this part today by drilling and doing some pocketing, so stay tuned. Now that we're back here, we're going to take a look and see where we left off. So last week, we ended up doing some facing and contouring the outside with adaptive milling, and then finishing the outer perimeter with our end mill. So let's cut out the inside of our pocket. So we'll do some 2D pocketing. So if we go up to here, we can click on 2D pocket. So we'll click on that. And a 3/4 inch flat end mill may or may not be able to get in here. So how would we figure out how it would fit? So let's find out by using this inspect button. And we'll click on this perimeter to this perimeter, and it looks like we have just enough to get an end mill in there. So maybe we'll step down to a smaller size. So 3/4 inch, that may end up violating some of these surfaces, such as this or this, when we go to do our slotting. Doesn't give us enough to do a finish pass. So let's go up to pocket, 2D pocket, and let's create or find a tool. So if we go into our Fusion 360 library, we last touched on how to import some of these. So we can either scroll through the list, or we can use our filtering options over here. So let's use a flat end mill because we don't have a radius in the bottom of that pocket. And let's go to a 1/2 inch flat. And what I'm going to do is I'm going to click and hold and drag it up to my setup here. So this is going to import it into my document. Okay? So I'm going to click on this, and we do have our options here once again. So let's go to low carbon steel, and we can pick any of these, or we can create our own parameters. So for now, I'm just going to expand this and then drag it down to low carbon steel, which we did for the last operation. What I could do is I can select roughing if I wanted to, and that'll change our feed rate. So you can take a look here, 19 inches a minute versus 24 for finishing, or even slotting for 21. So let's just pick roughing for now. And we can edit these as we go along if you wanted to. If you have your own parameters set, that's cool too. So let's take a look. We got spindle speed, we've got 500 RPM, and we'll select those feed rates and press 800 without pressing enter. And I have my spindle speed changed to 6,111. If I wanted my ramp spindle speed, I think we covered this earlier, I can delete this, and then what I could do is type in tool. Now I can look for my tool RPM, or spindle speed, and that'll be my ramp spindle speed will now match my spindle speed, as you can see now. And then my feed rate, I can do with the same with my lead in and lead out and ramp. Okay, so I'm going to type in with my feed per tooth. I like to use a expression, and this is typically diameter, which would be tool diameter divided by 150. And now that gives me a feed rate of 3,3/10. Now that's the way I like to use it. If you have a different way of calculating this out, that's totally up to you. Or if you have a set parameters based on a manufacturer specific variables, then that's totally fine as well. Let's just set that at 50. Okay, so now we're at our geometry tab. And we can do our contour mode. If we have multiples of the same pockets, we can do pocket recognition. Or I can click on this surface. You can click on this area as well if you click on this chain, but this will actually chew out this whole centered spigot. And that's not what I want to do. So if you wanted to edit a chain, you can click, hover over top, and then click while it's red, and then you can click on delete current contour, or you can click the X right beside. Now I want to do the inside pocket here. So if I accidentally selected the outside perimeter and then I wanted to select the inside perimeter, that would achieve the same thing. But the easiest way to do it is just select the surface if you can. So I've just selected our pocket, and we can choose our stock contours. Now this is going to recognize area around our part, so we'll ignore that. We could use wrist machining, but that is only applicable when we've used a previous tool to cut out some material. Wrap tool path is for using fourth axis pocketing, and then tool orientation is using multi-axis as well. So I'm going to leave these unchecked. I'm going to click on heights, and I want to set my retract height. I'm going to set that at 2 inches, and go back to edit and set my heights. My most important one is going to be my selected contour or bottom height. This is going to tell it the very furthest depth that it needs to go. So I want to cut out this whole pocket, this entire length of this wall. So that is set to this current contour, so this bottom base. And we don't want an offset, and we'll just leave that as is. And these defaults usually are pretty good. So I'm going to go to passes, and I want to set my finish pass, and this is going to give it a little bit of a spring pass. So if I uncheck that and hover over top, it shows us what happens. So we could rough it out, and if we were going in with another tool, we could do a different, like a contour tool path. But in this case, we can do 2D pocket and do the entire pocket and a finish pass all in one tool path. So let's click on Finish Passes. And I like doing a spring pass. So one pass, it cuts out a little bit more, and then the second pass trims off any deflection that the cutter would leave. So my step over, I sometimes like to have 2 thou. Or if you wanted to, you could, if it was a really long wall or a deep pocket, you could set this to 0, and it would do a spring pass and take out any deflection left with the cutter. Sometimes you have to do that with very long end mills. So we'll put leads on finish passes. This allows you to enter the wall and exit the wall gradually rather than just kind of engaging the stock. My finish feed rate, I like to usually change this down generally about halfway, and you can set a variable or you can type in 30 inches a minute. So if I wanted to go feed cutting, I could put that at divided by 2, and that would set my feed rate at half of what I was going for my roughing. I can also repeat the finish pass, so that would be essentially a spring pass, which I was talking about earlier. Okay, but that's also built into here. Finish overlap is when it leads in and then arcs in and overlaps in between the lead in and lead out, as you can see by this little picture here. So that can sometimes be handy to make sure that the entry point of the stock is cleared out that's tangent to the cutter when it enters in. Our maximum step over is 1/4 of the cutter. This is okay if you're doing shallow depths. If you're doing a deeper depth, you want to make sure that this is a very small amount. I usually think about 10% of the cutter diameter. And we can also specify that with a variable as well if we were doing high-speed machining. But we're not using 2D adaptive for this toolpath, which you can also use. But we're going to use a step over of 50%, so that would be 1/4 inch. Then that way we can make sure that there aren't any cusps in the material. Sometimes it leaves little step over islands in the middle. So if you look at this picture here, this allows the step over cusps. In some tool paths, if you do too much of a step over, like 75% or 80% on certain CAM softwares, they will leave these little islands in between passes. So this option allows that just for roughing operations if you have a finishing afterwards. Now, morphed spiral machining can be pretty cool with clearing out material, a little more gradual. It can leave a nice pattern if that's desired, but it can overlap constantly and not take out much material, so it increases the tool path time significantly. So we'll try it without for now. Now I want to set a multiple depth. My maximum roughing step down is going to be half of the diameter of the cutter. So I'm going to go 0.25. So we're going to go a 1/4 inch step each time with a 1/4 inch step over going 50%. Our finished step down, we'll do 1. And the finished step down, I like to usually do about 10 thou. That gives us enough material to actually grab onto and peel it out. We have 0 wall taper angle. This is a steep angle, 90 degrees. We're going to only finish at final depth. If you have this unchecked, it will do a roughing pass around, then do a finish pass, then a roughing pass down at the next depth, then another finishing pass. Now we have a cutter that's long enough to engage the entirety of this wall. So let's click on finish only at final depth, because sometimes that can increase your cutting time by a significant amount as well. If we wanted to use even step downs, that would take an exact same cut as a multiple of our depths. So then we take 1/4 inch, 1/4 inch, 1/4 inch, 1/4 inch, all the way down the wall. Or it would take 0.189, depending on the size of the wall. Okay, so that can, if you use even step downs, it gives a uniform look. Whereas you might get, if you used even step downs constantly, you might actually wear the tool out at a certain point on the cutter, and that will leave a line around your wall. If we were doing order by depth, this is really handy for having multiple pockets on really thin parts. Now, that can help when you have a thin wall in between. It would reduce chatter by ordering them by depth. We're going to leave stock on the walls, 20 thou, 20 thou. This can be used for an instance where you would measure your pocket, and then you can do another pass afterwards to get that to the perfect size, whether you're using wear compensation or just you using the software itself. So we're going to leave these passes, okay, on stock to leave, both 20 thou and 20 thou. Now, this is going to allow us to create a derivative of this toolpath, which copies all of the settings over, and then we can just manipulate just a finish pass at the final depth, so that when we go to measure it, we stop at this toolpath, and then we go to measure, and then we can run the remaining toolpaths to get it to size, as long as everything is within tolerance. Okay. So let's go to linking, and this is where we can preserve our feed rates for rapiding around the material. The safe distance is the distance between the tool and the part. Okay, so I like to have this probably within 100 thou. We're going to keep our tool down. Now this can interfere with walls such as this. So just keep in mind that it might lift up and then chew through the wall. So just watch out, and we can always use that back plot to verify our tool movements. Our maximum stay down is going to keep your tool down within a specific range, within this 2 inches in this case. I usually like to have it about 300% of the cutter so it doesn't jump up and do large redundant moves, which would slow down your tool path time. We're going to leave this at 0. Our leads and transitions, we should be okay with 50 thou on our horizontal lead-in radius. We also have our linear lead-in distance, which will be the straight line. This is a reasonable amount, and everything seems to be all right. I'm going to change my ramping parameters to zigzag. Now Zigzag allows me to kind of move back and forth, and then it starts to cut around and open up the material. Now there are different options, and you can mouse over that will, if you had a pre-drilled area, you could just sink a drill through the material and then plunge your drill right, or your end mill right into that drilled out area. If we had a plunge out, it would just drop into an area where there might not be any material present, very similar to pre-drill. But pre-drill, you get to select your location. Profile will actually arc in along the profile of the pocket, and the smooth profile I think is very similar. So let's go zigzag, and ramping angle I like to set to 1 degree, 2 degrees is usually pretty good. It all depends on the cutter. So let's set that to 1 and go back. And we can also have an opening, so it will ramp out and open up the pocket so there's a little bit of clearance. So our ramp step overs is going to be 1 inch. So it will move over 1 inch, move in another inch, and just kind of ramp in. Our ramp clearance height will start 100 thou above the surface. Our radial clearance, this should be, sometimes around 100 thou. That'll keep away from the walls so you don't violate those surfaces. So I'm going to set 100 thou and we'll see what happens. Our helical ramp diameter might only be applicable to the helix operation, and our minimum ramp diameter is similar. So let's try it out. Click this and let it generate. Let's simulate our toolpath. And it ramps in. Let's redo that. So it's going to come down 100 thou, then start ramping. And it keeps 100 thou away from the walls. And then it starts to open up a slot. And then it will cut down to 1/4 inch and start chewing out this material. And it'll do this repeatedly over and over. And then at the bottom, we will do our 10 thou finish pass once this roughing pass is done. And you can see how shallow it is. And we're doing our finish passes around our diameter here, and we're doing another finish pass around the outside perimeter. So that has roughed out the pocket. We have 20 thou on the walls and 20 thou on the floor. Now if I wanted to right-click on this and go to Create Derived Operation, I can go to 2D Milling and Pocket, 2D Pocket. This copies all of our settings from the previous operation. As you can see, everything is the same. Now, I'm going to reduce my multiple depths, or uncheck that, and turn off stock to leave. Now this will cut the rest of the material out that we need for finishing this part. Now you can see that there are a significant amount of passes for ramping in. So let's go back to Edit, and we can turn this off, or if we wanted to, we can go up to our heights. Now our top height is not actually stock top anymore. Okay, this has 20 thou on the top face. This one should be 20 thou from the selected contour. Click OK, and now it regenerates. And then it ramps in 100 thou from the 20 thou that we left. Now we need to start working on this area here. So best practice is to drill out, center drill out the hole, and then we can pocket this out and then do our countersinks and our chamfers, or our tap. So let's do that. Let's go to drilling. So that'll be up here. We can drill this hole, and we want to create a new tool. So I'm going to go to my Fusion 360 library, and we're going to use the same tool as our chamfering tool. So normally you would set a center drill, but in this case I'm going to pick a spot drill, and this is going to allow me to chamfer all the edges as well as providing that nice guiding point for the drill. So I'm going to pick low carbon steel. We have finishing or drilling. Now this is sometimes carbide, so I'm going to assume that it's carbide for this case. And I'm going to leave my, let's change our spindle speed, and my plunge feed rate, feed per revolution, I'm going to specify my expression that I like to use. So tool, feed, or diameter, divided by 150. Click OK, and there we have 20 inches a minute at 8,000 RPM. Now 20 inches a minute is quite quick, but we are also spinning at a very large RPM. We go to geometry. Now we have nothing selected right now, and we have a couple of options. We can select points, diameter range, if you have multiple holes. I'm going to select faces, and I can just select this one. Now if we had multiple holes, we can click same diameter and it'll select all of them, which is really cool. And you can see in my little shadow here, that's going far too deep. Now I want to use these existing settings as is. I'm going to change my heights. Now my bottom height, I'm going to click on hole top. And this might be, actually, let's do selection. So selection, and I want to pick this top chain because this is 30 thou lower. So click that top selection. And because this is center drilling, I'm going to go half the diameter of my spot drill. Okay, so if it's 3/8, 90 degrees, then I would go minus 0.187, and that will go just up to the edge of the point. So if I went 200 thou, you'll see that there will be the diameter, the full diameter or shoulder would be there. So I'm going to go 187, and that parks it right at the top there. And we're not going to drill through the bottom. We just want to spot this out for our next drill. And we're going to drill out by rapiding, because we're only plunging in so we can get that material out for the drill. Now, I can either create a derived operation, or I can straight up copy it, or even duplicate it for that matter. Okay, but when you do copy, so if I go copy, I have to click on this and then click paste here. And it drops down here. I'm going to edit. I'm going to create a new tool. Now this hole is going to be a 5/8 11. So I'm going to go to my Fusion library. I want to select a drill. Now 5/8 11 is 0.625, right? So 5 divided by 8 is 0.625, so that's my diameter. Now I want my minor diameter for my tap drill. So I'm going to subtract the pitch. So the pitch, if it's a 5/8 11, so that was 1 divided by 11, and that gives me a pitch of 90 thou. So I'm going to go 0.625 minus 0.09, and that gives us a 534 drill. And the closest thing is going to be a 1730 seconds. So if I wanted to go 1732, that gives me 531. So we're 3 thou off. So I'm going to find a 1730 seconds drill. Right here. We're going to pick low carbon steel for drilling. Actually, let's drag it up to here and make sure that we have it selected for low carbon steel drilling. Now this is going to be high speed steel typically. I'm going to set this at 90 surface feet per minute. Leave it there as the default. You might be able to increase it to 100, 110, but 90 is usually pretty fair. Now my plunge feed rate, if we take a look at this expression, we have a default. Now I'm going to go into my edit expression here, and I'm going to type in my tool diameter divided by 150. And since I have 2 teeth on this drill, I'm going to select that. You can set the variables as well. So now this is going to go in at 4 inches a minute at 647 RPM. So let's go to our geometry. And this is using the same hole. So I'm going to unselect this hole, and I'm just going to select this whole face. Now let's change it to selected points. And then this way, we can just click on the top of that contour, and then click on heights. And you can see our drill point kind of sitting there. And I'm going to change this to my select. I'm going to leave it at selection. I'm going to change my edge. Now this is going to be this bottom part. And now you can see that even with our little offset, we have 187 thou sticking out from the bottom. Now, normally it would be sitting just like this. So I want to compensate for my drill tip. Now you can click on this button, which will actually allow it to drill through the bottom. Or you could do a multiple. It would be 0.3 times diameter, which is 0.531. But we would have to specify a negative. So then that gives you the same thing. But sometimes that might be a little more cumbersome. But if we do drill through the bottom, and my offset is going to be 0, I want to break through at least 50 thou. Now this is going to be a positive number. This would be a negative number because you want to go lower. Now because this is a breakthrough depth, it would be a positive number. Now you can see where everything is kind of landing. We're going to drill it and wrap it out, but we're going to do some deep hole drilling. So you can see, actually, let's do chip breaking. So this will do a partial retract. We'll do a pecking depth. Let's go 0.1. Pecking depth reduction. So this can increase your time or increase your production rate. So it will drill a little bit more each time the further it goes down, or drill a little less the further it gets down. So on my minimum pecking depth, my accumulated pecking depth, this can peck until it forces a full retract. So we're going to leave that as default. Our peck distance, so this is going to drill in and then relieve. So every 100 thou, it's going to break off at 10 thou. It's going to retract and then come down another 100 thou, then retract 10, and down another 100 thou and retract 10. We're not going to do a dwell before retract. So we'll click OK, and now we'll see that it drills a hole all the way through. Almost entirely. There's a little excess stock there, but you can see that there's a hole there now. Now I'm going to create a duplicate because we copied the last one and we derived the one previous to that. Let's click duplicate. Now I'm going to edit this and select my tap. So we want a right-handed tap. We'll go to our Fusion 360 library and we want a 5/8 11. 5/8 UNC 11. We're going to copy this over to our job here, and we're going to use a default. Okay, I would not recommend going over 500 RPM just because it needs at least 3 times the pitch in order to sync the servos with the spindle so you have good timing. So that does reduce our service speed, but it allows us to accelerate and decelerate without much issues, especially if we have a blind hole where we might have a floor at the bottom, and if we go too far and too fast, then it drifts and you would break your tab, which is not fun. So let's go to geometry, and we're using the same hole point. We're going to use the same options here, and we can do our drill breakthrough depth. Now let's just keep all these settings the same. This is the same as our actual drill. We don't have our right-handed tapping cycle selected, so we're not going to ignore the warning. We're going to go to our cycle type and click on tapping. We don't need a dwell period, and we'll click OK. Now this is going to tap all the way through our piece. Now what might be better is when we do some rearranging, we would clear out this hole with our end mill and then open it up and chamfer all our edges, then tap, which is what we're going to do. We're just going to rearrange this, and you can see how I click and drag things around. So we need to open this up. We're going to use a pocket. So we'll click on 2D pocket. We're going to use our 1/2 inch flat end mill. We're going to drop the feed rate a significant amount, because in a small hole like this, it can be just rocking away and it goes a little bit too fast for some machines. Newer machines won't have such an issue. But I like to go probably 30-45 inches a minute in a hole this size. So we don't need to go 60, so let's go 35 inches a minute. It does reduce this a little bit. And we're going to go up to our contour, and we're going to select this hole. So now we want to do the inside, so that's why I picked the contour rather than the floor. As you can see how it's highlighted. So you pick the contour, and we're going to go to our heights. We have a selected contour. All our options should be all right here. If we go to passes, I want to do a maximum step over 10%. So this is really handy if you go to edit expression. What we can do is take our tool diameter and multiply it by 0.1. So that'll be 10%. So it's going to step over 50 thou each time. Now, or you could do specify your actual size in here, whichever. If you're comfortable with 30 thou or 50 thou, that's totally fine. We're going to do a finish pass. Let's just do one finish pass. This size isn't critical. It's for socket head cap screw. And we're going to do a step over of 10 thou. I'm going to put some leads on. Our finish feed rate is 35 inches a minute. This might be okay to drop down maybe 15 inches a minute. We're going to ignore multiple depths. We're going to turn off stock to leave, and we're going to go to our linking and see how we have leads in. I'm going to leave these and see if they work. We don't need a ramp. We have a hole right in the middle, so we're just going to plunge. And if we have any issues, then we can always go to pre-drill. So let's click OK. So this should drop into the middle of the hole and spiral outwards and then clean up the walls. Let's just check it out. Let's slow it down. We can even do the next move, and it drops right down into the middle of that hole, or very close to it, and then it will spiral out. And then do our finish pass, come back to center, and then wrap it out. So now we have that ready for our countersink. So let's do some contours. So 2D contour. We're going to select our 3/8 spot drill. We'll use our low carbon steel for finishing. Click OK. And we'll set this at 800. And I like to have a good chamfer. So something that might not have the little tool marks in it, you can go about 30 or 40 inches a minute. So we'll go up to geometry. Now this says selected contours. We're going to select the inside contour. And you see how this little arrow is? That tells us that we want the cutter on the inside or the outside. Currently it's on the outside, so we want it on the inside cutting this chamfer. Otherwise it's going to put a chamfer right down the middle on the opposite side of this line. So you just click that arrow and it will change sides. But I don't want to do that one just yet. I'm going to select this one on the inside, and we will go up to our heights and selected contours. I'm going to change this to selection. So I want to select this height. Now I picked this contour for my inside. That's going to be the hole, or the edge of the hole. Okay? This is going to be the actual height. So we have to adjust that. So we leave our offset to 0. And we're going to go to passes. We don't need to do a finish pass because this will be it. We're going to leave this at 40 inches a minute. We're going to scroll through all this. We're going to chamfer. Now our chamfer width, we can measure here by clicking the Inspect button and clicking those. So this is 60 thou. So let's go back and type in 0.06. Our chamfer tip offset. This is important so that the edge of your tool is not dragging right along the center, kicking a burr outwards. We are chamfering to get rid of all the burrs. So we want to have this offset just a little bit past so that it takes off this entire edge and whatever comes off with it. So this is something that you might want to put in 30 or 50 thou. So now you can see that it's slightly dropped in. And if I go back to my chamfer, this amount should never add up to more than half the diameter if it's 90 degrees. Now going back, I just want to check my lead in and lead out to make sure that we have enough clearance on the back side of the wall, because sometimes these might be too large to even fit into the hole, and it might give you an error. So this cleans up that area. So if we simulate this, we step in, I'm going to get rid of my holder. We'll just do flute. And we step in. And we'll slow it down and play it. So it arcs in. And if I wanted to pause this, I can change my visual settings to wireframe. And I can have hidden edges or just a wireframe. If I get rid of my opacity for my stock model and get rid of stock, well, now I can see where things are going to touch. And you can see where my edge is, it's hanging over. So it comes up to that edge, it's tangent. So now if you had this point right here, that would be creating a burr on the other side of this point. So that's why we have it overhanging. So it goes around and produces our nice chamfer for our screw thread. So simulate and turn on my stock. And I have my model opacity. So we don't have any lines. So visual with visible edges only. So now if I check on that, I have my chamfer here. Now I need to create a chamfer here, here, and here. If you had the same chamfer as on every other edge, then you could use the same toolpath by selecting those contours. However, these ones are all different. So we have to create or duplicate additional options. So now this chamfer here, and we may as well set these. And what is it? 30 thou here. We have 60 thou on that one. 71 thou. So we're going to use this contour. And we'll go up to this, select this outer chain, change our height to selection, and we have our chamfer width, and we click OK. And you can see we're cutting that right off. We can also have a toolpath where we do 2D chamfer. So this is a little bit smarter. So we keep our 3/8 spot drill, contour selection, now these are going to be 50 thou. Our selected contours, we'll select the top height. And our chamfer width, 0.05, chamfer tip offset, and we can have chamfer clearance as well. Now this just stays away from certain walls if you're chamfering a shoulder that leads up to a boss or something like that. We don't have any of those walls or open contours, so we're just going to leave it as is. So let's click OK and see how it turns out. So now it looks like it's violating that surface because we picked the inside edge. Let's find out what's going on here. So we picked the inside edge rather than this outside edge. So let's delete that and then open that and pick that. And now it looks correct. So now I want to reorganize my tab. So I might as well keep these tools the same way. I'll take my tab and drag it, click, and hold it, and then drag it until you see that line where it's going to drop. Now it's going to put it right down at the bottom there. This way we can organize our tool paths for efficiency, so we're not having to drill and then change a tool to our countersink, and then we have to change it back to a tab. Well, if we just chamfer all of these edges beforehand, we save that time going up, changing the tools, and coming back. So let's verify, simulate our part. So we're going to face it off. We're going to go around with our 2D adaptive. So then we finish the part on the outside, and then we ramp in and pocket out this inside area. Look at it go! And then it does a semi-finish, and then it does its finish pass. So then you can measure it in behind. And then we're going to plunge, and then we chamfer, and we have it drilled, and there's our drill. So that's the first side done. We've made it this far, so pat yourself on the back. So now we're going to create a new setup. Because this is side 1, we'll go to create new setup, or what we can do is even copy this. But let's create a new one because it's been a week. So let's click that, and we're going to keep pretty much the same settings. We're going to select the Z-axis plane, and we're going to pick this face. Now this looks good. It's usually good to flip it end over end. So if you have a feature or something over here, it's best to flip it this way in your milling machine so that you're not forgetting which side has a specific pattern. And I don't think I need to pick the wall, but if you wanted to, you could pick the x-axis wall. See, it didn't change. And then we're going to pick the model origin. We're going to pick the select model box point. And we're going to keep it there at the center. We're going to use from the preceding setup, so it knows what stock we've machined. And you can do continue rest machining, so then it shows you what has already been cut off of this block. So really all we need to do is face it and then contour this back, or this outside. So let's copy this face, copy, and then click on our setup number 2, and then paste it. So if you don't see any toolpaths here, click on the little drop down, and now I have 2 facing operations. I'm going to delete one of those, and let's go into edit. We have the same parameters as before. Then we simulate, and it shouldn't leave any excess stock. So now I'm going to cut off the outside, and we can just use a 2D contour. We could use this same tool if we wanted to, or if you wanted to have a uniform, use your same tool as your finishing tool. And I believe what we used last time was a 3/4 inch end mill. So usually pretty good to use those again as well. It's just so you have the same diameter being cut and it's consistent. So I could even use this toolpath just by copying and pasting. So half the work is already done, which is really nice. So then we'll edit, change our contour selection. Well, this is exactly what we want. We're going to leave all the settings. We're just going to regenerate. So now you can see my toolpath is a little bit higher because we had an offset of 0.3, so we didn't hit the vice jaws. Now I'm going to go back into my edit and set this to 0. Now this would cut that line. Now I know that there's 0.3 left over, so we need to go, let's go 0.5, minus 0.5. So now this should be able to go around, cut the edge. Looks like it's working out. I also want to make some finish passes because there's going to be a fair amount of stock, especially if I go around in one shot. I want to add another finish pass just to make sure that that deflection is not going to be there. You won't have a line or a more prominent line around if we do that. So if we go to edit, we go to passes, and we can do multiple finish passes, 2 passes, step over at 2 thou. Let's change it to 3, just to make sure we take all the deflection out. I'll click OK, and let's simulate it. Once, twice, third time, goes around. Now, one issue that I might have with this, go back to the beginning. You see this excess stock? I might be plunging right into it. So I'm dragging the tool over. Now that might be okay in most instances. That might be a ton of material to take off. We should be okay. That's a 3/4 inch end mill. That will be able to take it. However, if I wanted to get it further away from the part, just so it doesn't drag down there, it drops down and engages the material gently, I might want to go to my linking and then change these lead-in parameters to greater values. So let's go 1/8 of an inch on both of those. So this would be the radius, this would be the lead-in straight line, and let's take a look. And you can see that I've got a greater distance from that stock. And now as it engages, it's a little more gentle. So pat yourself on the back, guys. We are completed this part. And I will be doing a lathe video next. So keep posted, hit that subscribe button, and let me know what you guys think. Thanks for watching.